Hello guys, welcome to my YouTube channel again. I am back after quite some long time. और अभी मैंने जस्ट लीड कोड वीकली कॉन्टेस्ट 473 में पार्टिसिपेट किया था ऐसे ही फन में और आई वॉज एबल टू सिक्योर अ गुड रैंक एंड आई फाउंड द प्रॉब्लम सी एंड डी क्वाइट इंटरेस्टिंग लाइक द कॉन्सेप्ट इज़ ईजी बट इट रिक्वायर्स a bit thought, so I thought let's make a editorial video of the problems A to D of this contest. So let's start. ओके सो अभी भी कॉन्टेस्ट ख़त्म नहीं हुआ है बट मैं ये जो वीडियो है ये कॉन्टेस्ट ख़त्म होने के बाद ही आई विल अपलोड. सो लेट्स गो ओवर द प्रॉब्लम्स. पहले सारे प्रॉब्लम्स एक बार ओपन कर लेते हैं. C D, right. So the first problem says remove zeros in decimal representation. Acha, while explaining the approach, I am assuming that you have a bit of programming knowledge. So like for the easy ones, I will not be going in depth, right? So you are given a positive integer n. The question asks you to return the integer obtained by removing all the zeros from the decimal representation of n. So जैसे कि इनपुट में दिया हुआ था 1020030. तो in this integer after removing the zeros, like remove the first zero here, remove this second zero and remove this third zero, and finally remove the fourth zero. So the remaining number after the remaining concatenated number after removing the zeros is 1 2 3, and you have to just output it, right? So this is a pretty easy problem since the constants is pretty low, like 10 raised to the 15. But also the constants here doesn't matter actually. So what I did here was that I just converted the number given to me into a string using the C++ STL toString function, and then I iterated over the string from left to right, right? And whenever and also I am forming my output number at each iteration of the string. So okay, so like let me explain it. Like explain it a bit here. So, like how I did it. So for example, the number is 200. What was the input? 100 200 30. All right. So okay, so for example, I am at the fourth index, let's say 0 1 2 3. Okay, let's say that I am at the third index and I have already found my answer until 1 2, right? So at the fourth index I encountered 0. I just skipped it. I just skipped the loop. At the fifth index I encountered another 0. I just skipped the loop. And at the sixth index I encountered a non-zero integer. So what I did here was that I just did 12 like my current formed output number into 10 plus 3. So that will be 123. So this is a simple intuition and it was quite easy. So I just iterated over the loop, and if the current integer sorry, not integer, the current character, since I converted it into a string which is an array of characters, I just did this step here which I mentioned in the solution. So and just finally return the output. So this was a pretty easy problem and it was obviously problem A. So this is done and dusted. Let's now move over to the second problem. This one was also another easy problem, I would say, but let's go for it. So you are given an integer array nums. You may rearrange the elements in any order. The alternating score of an array is defined as score equals to the error 0 square minus error 1 square. So basically, if you are given a whole array, for example, the array, look, let's remove this. For example, let's say you have an array of integers a1 a2. Okay, let's go with zero based indexing, a0 a1 a2 a3 a4 a5, right? So the alternating sum of this array will be a0 square. How to do square here? I will just do a0 into a0 minus a1 into a1 plus a2 into a2, so on, right? Minus a3 into a3, and this will go like this. So basically the sum of squares of the values in the even indices minus the sum of squares of the values in the odd indexes of the array. This is what you have to do. So the initial thought which will come to your mind is just sort the array, right? Because we want to maximize this value. So what we will want is that place the maximum value numbers in the even indexes of the array, since they are adding since they are contributing positively to our answer, and place the small valued numbers in the uh, odd indexes of the array, since it is just decreasing my answer, right? This is the initial thought. And also, like, there is one catch here, since we are squaring the numbers, so the sign of the numbers doesn't matter here, right? Because uh, whether it is 3 or minus 3, the contribution for both of these numbers is 9 only. It's right. So 3 and minus 3 both are equal here. So it was just the simple problem here. So what I did was that initially, if the number is negative, I just converted it to a positive integer, right? And then I sorted the number from the in descending order, right? Then what I did was that, okay, and like there is one like you have to handle the odd and even cases. So for example, let's say the array is of size 5, right? So in this case, you will add the positive integers in the first. Okay, so in this case, the output will be a0 square, a0 into a0 minus a1 into a1 plus a2 into a2 minus a3 into a3 plus a4, sorry, I think I made some mistake here, a0 minus a1 plus a2 minus a3 plus a4 minus, I think this is right, yes, 1 2 3 4 5 1 2 3 4 5, yes. So right, so here I will place the first 3 big integers in the even indices places, like a0 a2 a4, and the remaining 2 small integers in the odd indexes places. So this is pretty easy to do. Like first, like take half of the array and add it, and add the sum of squares of their values to your answer. Then iterate over the like later half of the array which contains the smaller elements, and just subtract the sum of squares of their values to your answer. And in case of odd size array, you will also add like in case of odd sized array, the first half of the array will have size n by 2, that is 5 by 2 plus 1, that is in case of here 5 by 2 plus 1, which is 3, right? So you will add 0 the first half of the array, which is 0 1 2, to your answer, and you will subtract the second half of the array, which is 3 4, from your answer. So I just did the simple thing here. I just sorted the array. Okay, so like this sub index represents the index from which I need to subtract. So initially it is n by 2, and I just initially added the sum of squares of the first half of the element, that is up to n by 2, to my answer. Now if n is odd, which I mentioned this case here, I just increased my sub index, because sub index, like the index from which I need to subtract, will not be n by 2, it will be n by 2 plus 1. So I just did sub index plus plus here, and also included the particular index n by 2 in our addition part. And then I iterated from some sub index till n minus 1, and just subtracted the sum of squares of the values, and just outputted the answer. So this was also another pretty easy problem, I would say. So now let's go over to the two interesting problems, which are problem 3 and problem 4. Sorry. Okay, I think recording is on. Yep. Now let's move over to the interesting problem 3. So in this problem you will be given an integer array capacity and a sub array capacity which is from index L to index R is considered stable if its length is at least 3. So subarrays of length 1 and 2 are not considered as stable, so the length should be at least 3, and the first and last elements are each equal to the sum of the elements strictly between them. Okay, so capacity of L should be equal to capacity of R, like the first element is equal to the last element, and these both values are each equal to the sum of the all the values between these two elements, sorry, between these two elements, and return an integer denoting the number of stable subarrays. Okay, and what is a subarray? It's just the definition of subarray. If you are watching this video, I assume that you know what is a subarray, otherwise there is no point in watching this video, right? So let's go over to this problem once again. Let's just erase all of this, right? So okay, so for example, okay, let's take one example only. For example, here is one example, right? So yes, so in this example, this whole subarray, like the whole array which is also a subarray, is a stable subarray. Why? Because the first element value is 9, which is equal to the last element value is also 9, and which is also equal to the sum of the elements between them, which is 3 plus 3 plus 3, which is also 9. So this is a stable subarray. Also this subarray of this whole array 333 is also a stable subarray because the first and last elements are equal and the sum of the values between them is also 3. So 333 all equal, right? So initially I was a bit confused. Okay, so now let's go over to the intuition behind it, like how I thought the whole thing. So initially while thinking about the problem, I thought in these kinds of problems prefix sum comes a bit handy. Okay, so I thought let's go over to the prefix sum type thing, right? So let's try to do this. So let's say that you have an array like this, a0, a1, a2, a3, a4, something like this. Now let's say I have computed the prefix sum of this array. So pref of I contains sum of all elements, from index 0 till I, right? So can we just reformulate the stable sub array definition with the help of prefix sum? I think we can. So how can we? Let's say that our stable subarray is from index L till index R, right? So now, so the condition of stable subarray is nums of L should be equal to nums of R. Okay, this is number 1. And also the sum of the elements from index and also the sum of the elements from index L plus 1 to index R minus 1. That is the sum of all elements between, after the first element and until the last element, not including the last element, should also be equal to this index till sum equal to nums of L, right? So I think we can reformulate this using the concept of prefix sum. Okay, so now let's do pref of R minus pref of L and let's try to find what is its value actually, right? So prefix of R means all elements from index 0 till index R. Now, and pref of L means all sum of all elements from index 0 to index L. So this value will include sum of all elements from L plus 1 to R, right? Okay, so and now, right, now we know that pref of, now let's write this once again. Now we know that we can do something like this: sum of all elements from index sum let's take this plus nums of r. Okay, so sum of all elements from l plus 1 to index r is equivalent to sum of all elements from index l plus 1 to r minus 1, and like I am just adding the value at index r separately, right? Okay, now pref of r minus pref of l can be written something like this. Okay, now the condition of stable uh, like subarray is that this value should be equal to nums of l, which should also be equal to nums of r. Okay, so we can just write it at nums of r, right? So this is the catch here. Now 2 into nums of r, right? So we got something like this. We formulate a good formula. So this is the actual formula which you can find out from these equations. So now we can do something like this: pref of r minus 2 into nums of r equal to pref of l. Alright, so now we have a quite good formula actually. Let's just put this in the little upwards. So this is our formula, right? Pref of r minus 2 into nums of r should be equal to pref of l. So if we are at index r, we can easily find our index l using this formula, using the standard hash map approach. Like I will show you, like it's a pretty standard approach, right? Also another thing, okay, but like this is not the only condition which we need to satisfy. This was the second like what's that called, this was the second condition. The first condition was that nums of r should be equal to nums of l, right? Okay, so now we can move over to, so like if we, okay, so now what my approach will be that I am at index r, so I will try to find all subarrays which are ending at index r and they are stable. I will show you how I will do this. We can do this using a pretty simple hash map approach. Okay, so so I maintain one hash map here. Okay, so so let's say that I am at index r, right? I am sweating making videos after a long time and anxiety. Okay, cool. So yes, so let's say that I am at index r. I want to find sum of all values. Okay, so find count of stable subarrays ending at index r, right? So to do that let's say, so when I am at index r, I am like I will obviously have the pref of r also, since I am just like adding the values of the elements in each iteration of the for loop. I will show you, like just be with me. Okay, so pref of r is with me, and of course nums of r will also be is with me, right? So I know this, the value in the left side. Now I will just have to calculate how many l's are there such that this value is equal to the prefix sum of that l, and also this nums of r should be equal to pref of l. So we can just do this using a map. So our map will be, let's say, pref of I comma I, right? If we just like pref of I, and like let's say you have a map here, and that mp of this like it just stores count of all indices having value this particular pair pref of I comma I and so for this, so for to count the number of stable subarrays ending at prefix ending at index r, I will just have to update my answer with mp of pref of r minus 2 into nums of r comma pref of r, sorry, nums of r, and this will be my answer. Let me explain to you like much more, so it will be crystal clear in your head. So basically these are the two formulas. So when I am at index r, I am calculating number of stable subarrays ending at index r, right? Now this has to satisfy two given conditions. Number one is that the value of the r should be equal to the value of l, okay, and also here, okay, so and also here l, right. This one is the one thing which I need to satisfy, and the second thing is that the pref of r minus 2 into nums of r should be equal to pref of l. Okay, so I'm at index r, I am just updating my answer with the number of l's such that l to r is a stable subarray. And how I am doing that? Okay, so I am just maintaining a map and mp of pref of and in that map I am storing this particular pair pref of I comma I, which is the count of all indices having this particular value pref of I comma I, right? And I can just iterate this, I can just update this map in each iteration of my array from left to right. So if I have this value, I can just easily update my answer for the current ending index r with pref of r minus 2 into nums of r, since this should be my value of pref of l, and comma nums of r, since this should be my value of nums, since, okay, so not here I, this should be nums of I, this should be my value of nums of l. So that's a simple question, solution here. So I'm just did what I've explained here. So this is my map, val index map, pair of int comma int comma int. Now this is my particular prefix and I am updating it in each iteration of the array from left to right. I think the contest has ended here. And now I am just updating my answer for this current index, like this value represents the number of sub arrays ending at index I, and all those subarrays are stable subarrays. Okay, so pref minus 2 into capacity of I comma capacity of I, the exact formula which I mentioned here, right? And I am then just updating my map with this particular prefix. Okay, now there is one edge case here, I missed this edge case, but luckily the problem setters are like quite nice. They included the edge case in this particular what's that called, sample, right? So let me just dive deep into this sample once again, this particular sample. Okay, so the case which I missed here was that the length of the subarrays must be at least 3. Now let's say that we are considered this particular array. Now here, according to our approach, 0 comma 0 will also be considered a stable subarray, since nums of l equals to nums of r. Now there are only two elements and both the elements are equal, so this condition gets satisfied. And also pref of r, like the sum of the values from this to this is 0, sum of the values from and minus 2 into nums of r is 0, so this left part is 0, and the sum of the values from pref of l, like this sum is also 0, so these two conditions get satisfied, right? So we have to exclude these two length subarrays from our answer. Then my mind thought do I really need to exclude all two length subarrays, or the problem is that only those two length subarrays in which both the elements are 0? The answer is that we will need to only exclude those two length subarrays in which both the elements are 0. Why? Let's say that my two length subarray is has values in which the elements are, let's say, x and x, and these are non-zero, right? So the first condition gets satisfied, but the second condition will never get satisfied. Why? Because pref of r minus pref of l, right? Because okay, so this is the formula, right? Let me just keep it here once, and just I will do I will just do it like this. Alright, so pref of r minus pref of l denotes the sum of the values from index l plus 1 to index r. So in this case, this value will be x, right? But this value will be 2 into nums of r, which is equal to x. So x can be equal to 2 into x only if x is 0. Like it's simple math. So x can be equal to 2 into x only if x is 0. So I just have to include those cases from my answer in which the index I and index I minus 1 both are 0. That I simply did here. Like if index is greater than 0 and the value at index I is 0 and also index I is equal to index of I minus 1, I just excluded this from my answer and just outputted my answer. So I would say this was also this was quite nice implemented, like nice prefix sum problem. So that's done. Now let's move over to the last problem of the contest, which is count distinct subarrays divisible by k. This is actually mentioned as a hard problem, but I found this also quite an like medium level problem only, like difficulty similar to the difficulty of problem C only, like the third problem only. So now let's go over to the fourth problem. So okay, so let's go over to the problem statement. You are given an integer array num sorted in non descending, like increasing, but the like not strictly increasing, non descending actually means, and a positive integer k, and subarray of nums is good if the sum of its elements is divisible by k. Okay, simple. Return an integer denoting the number of good subarrays of nums, distinct good subarrays of nums. So here is the catch, and here is the definition of subarray, and here's the definition of distinct subarrays. Okay, so let me explain this with an example. So for example, here my subarray is 1 2 3 and k is 3. So the good subarrays are 1 2 and 3. Why? Since the sum of the elements is 1 and 2 is 1 plus 2, which is 3, which is also divisible by k, which is 3. And also the whole subarray is also a good subarray since the sum of the elements is 6, which is also divisible by 3. So the output here is 3, since there are 3 distinct subarrays. But let's go over to this case, 2 2 2 2 2, like all 2's. So here the like let's go over to this case and explain this problem. I think this part is done. Okay, so here okay, I will just like write indices for this, right? So here index and k is here 6, right? I will be a little fast here since the video is already quite long, right? So here subarrays from index 0 to 2 is good since the sum of elements is 6, which is divisible by k. Index 1 to 0 to 2, 1 to 3, 2 to 4, 3 to 5, 3 0 1 2 3 4. Yes, all these subarrays are what's that called, divisible by k, the sum of the elements. Here 3 to 5 means the sum of the subarrays from index 3 to index 5, and also the whole subarray 0 to 5, since the sum of the elements is 6 plus 6 12, which is also divisible by k. So there are actually 5 subarrays which are divisible by k, but the number of distinct subarrays is only 2, which is 0 to since this subarray means it is 2 comma 2 comma 2. This subarray also means 2 comma 2 comma 2. And this subarray this also means 2 comma 2 comma 2, and this one also means 2 comma 2, and this one is the whole subarray. Right, so the number of distinct subarrays is only 2, so you will output 2 as the answer, not 5. So okay, so initially I thought, like, if we just remove the distinct part, isn't the problem quite easy? Like it's similar to the prefix sum one only. Yes, if we just remove the distinct part, the problem is quite easy. So let's first go over to solve the problem in which we will find all subarrays such that the sum of their elements is divisible by k, like not distinct subarrays, right? So let's go over to our original prefix sum only. So pref of I includes all sum of all elements from index 0 till I, right? Now what it is saying, pref of R minus pref of L, right? This should be divisible All right. What does this mean? Okay, so divisible by k means some quotient, let's denote this as q, into k. All right, this is as simple as that. This means that the sum of elements from index l plus 1 to r is a good subarray. As simple as that. Sorry, is a good, yes, it's a good subarray. Now let's modulo both these sides by k, ref of l modulo k, right? And this q into k modulo k. Okay, so this will be, and the modulo is like, we can distribute it like this. Okay, now the right part is 0 since this value is divisible by k. So this is 0, which actually means that pref of r modulo k should be equal to pref of l modulo k, right? So here is the formula which we got. This is the actual formula we need. Yeah, right. So instead of storing the pref, like the sum of elements in pref of r, if we just stored the sum of the elements mod k in pref of r, then when we are at index I just need to find all previous indices behind I which has the same modulo as pref of I. So at index r, I need to find count of all indices such that pref of r, pref of r mod k is equal to pref of l mod k. Now I actually have this particular value pref of r mod k when I am at index r. Now this particular value I can just store in a map like just in the previous problem, and I will just update my answer with the count of these many count of all indices which have pref of index mod k same as this. So this is a pretty easy problem. So first let's go over the code to the first problem. So I have just this is my map which is like val count. Okay, so there is one case this can also be a sub, right? 0 1 2, let's say this is my array, so 0 1 2 can also be by part of my answer, and in that case pref of r minus pref of r, it will be 2 minus pref of the left part will be minus 1, right? So actually I just updated the subarray which does not include any element, like the subarray at index until index minus 1, which is the value of 0. So I just updated the subarray the subarray having pref of pref of I mod k at index minus 1, and the pref I mod k at index minus 1 is 0 to 1, right? So this val count 0 1 means that, let me just explain it. I think my explanation is quite bad here. This means that sub array at index until index minus 1, until index minus 1, so it does not include any element, so pref of I at that index is 0 and mod k is also 0. So this pref of r mod k at this particular index minus 1 is 0. So I just updated it to 1, and then I just iterated over the whole array, and then I just did a prefix sum mod k. So this pref is pref of r mod k, right? Pref plus the current element mod k and the whole mod k, and then I just updated my answer with the number of previous occurrences of this pref mod k, and then I just updated my hash map. So now this, until this, my answer includes the sum of all the all good subarrays my answer includes, but I have to exclude the distinct ones, because if I just did until this, my answer will be 5 in this case, like the case which I discussed here, like all the elements are 2's, but we want to consider only the distinct ones. Okay, so initially like finding the distinct ones will be quite difficult, but we have a catch here. What is the catch here? The array is sorted in non-descending order, right? This was the hint which was enough to solve this problem. Since the array is sorted in like in increasing order, like non-descending order, so let's say my array is a0, a1, a2, a3, a4, a5, something like this, like, and a0 less than equals to a1 less than equals to a2 less than equals to a3 less to a4, right? Sure. Now let's say that I am at some particular index, let's say I, and let's say it's this particular index, right? How will I highlight this? I don't know, I'm just drawing here. So let's say that I am at index 3, a3, right? So, and okay, so let's say that my sub is something like this: 1 1 2 2 4 4 5 5 5 6 6 6, right? And let's say that I'm at index 5, right? So the number of subarrays ending at index 5 and all of them are good subarrays will not contain any duplicate, right? Why? Okay, so which subarrays including this, like the leftmost 5, can be part of my answer? Let me just write this quite fast. This one, now this one, now this one, now this one, now this one, and I think 4 5 and then 5, right? All these subarrays are these are all the subarrays which are ending at this particular, the leftmost 5, right? And as you can see, all of these subarrays are distinct subarrays, right? So if we did what we did like previously, like the prefix sum mod k approach, like for this particular leftmost 5 there will be no duplicates, right? Since all of these subarrays are distinct, right? Now for this particular 5, like the second 5, this will also be distinct. Why? For the same reason. Right, look, let me just write it here. This one is here, this one is here. Okay, no, there will be duplicates, but I will show you which one. Like it will pretty easy, it's actually pretty easy to find out. 4 5 5, then 5 5, and then actually 5, right? Right, got it. So here, like as you can see, all of these subarrays have these two 5s ending, but none of these subarrays have two 5s ending, right? Like all of these subarrays have two 5s ending, but none of these subarrays had two 5s ending, right? So the only common between these two subarrays is 5 only, like this 5, right? And let's say like I include another 5, right? Let's say that there is 555, then it will also be something like this. Like all of these subarrays will be distinct except the ones which contain only 5, right? So here is the approach. Since the array is sorted in distinct order, the duplicates will be including the only the subarrays which contain the same elements. This is the axiom which I am saying, and you can like think over it a bit and you will get it. Like, and I am also showing you using egg samples. Since yes, since the, and this is only true since the array is sorted in non-descending order. Since like whenever you just add an element, either it is a new element, in that case all the subarrays are distinct, or it is like a current element and some element appended to it, right? So this part is like distinct always, like the right part which contain the same elements, but like internally they might have same like subarrays. So we need to remove duplicates containing same elements only. This is the like bold statement which I am making, right? Now this is quite easy since the array is sorted, right? So what I did here, like just go for the code here. I just iterated over the whole array, and then I just found like the index I and the j, like the same element is repeating from index I until index j until index j. Like for example, this 5 is repeating from this index until this index. I just found it, and then I just removed the duplicates using this function and just return my answer. Now how will I remove the duplicates? Like, okay, now our problem has reduced to just this: remove duplicates in arrays containing same elements only. So my array is something like this, right? So it's pretty simple. Okay, so now here, like, okay, so here since all the elements are same, the three size arrays are all same, four size arrays are all same, right? But if let's say a 4 size array or a 3 size array is a good subarray, I need to include it only once. So for example, let's say that in this array the number of 3 size arrays is 1, like index 0 to index 2, index 1 till index 3, index 2 to index 4, index 3 to index 5. 3 size arrays count is 4, and 4 size array count is 0 to 3, 1 to 4, 2 to 5 is 3, right? So 3 size, and let's say that 3 size arrays are good subarrays, so it will be counted 4 times, but we need to count it only once, right? This is the only thing we have to do. So what I did was that I just firstly computed the sum of all the elements. Acha, I did a pretty bad trick here. Like this is like actually like doing nums of I r minus l plus 1 times only, but ठीक है, contest time में उतना दिमाग नहीं चलता, ठीक है? So okay, so basically, okay, now what I am doing is that I am just going to each length subarray. Like, okay, so my current count is actually r minus l, which is, let's say in this example, 5, right? Since the 6 length, like the whole subarray is only 1, so there will be no duplicates there. But if there are 5 length subarrays, there can be duplicates, since there are 2 5 length subarrays, and if 5 length subarray is a good subarray, it will be counted one time extra, right? So I'll have to subtract that extra part. So I am just running a while loop until the length of the sub array is 0. So, and like since and this sum contents is actually the sum mod k, so I am just like subtracting the particular element, like since all the elements are same, I am just subtracting the nums of l and mod k. Now if the sum is 0, which means that the sum mod k is 0, like the sum of the elements having length current count is 0. Okay, so this means that all of these elements are good subarrays. Now I'll have to subtract the extra occurrences of there, which is like r minus l plus 1 minus current count. I will explain this, like just be with me. And then I just decrease the length of my subarray and just return my answer. Okay, and this formula is quite simple. Let me explain it. So what is r minus l plus 1? R minus l plus 1 is 6, like index 0, 0, 1, 2, 3, 4, 5. So r minus l plus 1 is actually the length of my whole array, which is 6 here. R minus l plus 1 6. Now how many 3 size subarrays will be there? How many 3 size subarrays will be there? It's 6 minus 3 plus 1. This, like, you can just write it in copy pen, you will get it. So if length of array is alien, number of x length subarrays, x less than equal to alien length subarrays in it will be alien minus x plus 1, right? Yes, you can just do it using copy pen, you will get this formula, right? And since I have included it all, like I have to include it only once, I have to like not include it alien minus x plus 1 times, I'll have to include it just one time. So I'm just adding this alien minus x to my answer, since one I need to include, and thus returning it, and that's the answer. So that's all for this video. It has become quite long. Okay, my thing, my face cam was getting distorted, but that's okay. So this was the video. I hope you guys enjoyed it. I'm making videos after quite a long time, so happy weekend. Bye.